Welcome to this video on controlling PCB trace impedance. We will be bridging the gap between ideal theory and real-world performance for signal integrity. Impedance is the electrical relation between current and voltage. In high-speed design, it is crucial for signal integrity. We distinguish between the mathematical, ideal world, and the physical, real world. When modeling real devices like a ceramic capacitor, we consider factors beyond ideal capacitance, such as equivalent series resistance, or ESR, and equivalent series inductance, or ESL. The fundamental relation remains Z equals V divided by I. Impedance changes with frequency. At low frequencies, a device acts like a capacitor. At resonance, it acts purely as a resistor where ESR dominates. At high frequencies, it acts like an inductor, and impedance increases due to ESL. Characteristic impedance, Z0, is the instantaneous impedance a signal sees as it travels. For a uniform transmission line, this impedance remains constant and is determined by the square root of L over C. Uniformity is key. A uniform line ensures the characteristic impedance applies across the entire length. Non-uniformity leads to signal reflections and discontinuities, compromising signal integrity. An impedance discontinuity, like a change from 50 to 80 ohms, causes a signal reflection, known as the glitch phenomenon. This mismatch results in steps and oscillations in the waveform. A common solution is to terminate with matching resistors. We can physically control characteristic impedance. Increasing trace width or copper thickness leads to increased capacitance and decreased inductance. Both result in an overall decrease in Z0. Dielectric properties also affect impedance. Increasing dielectric height decreases capacitance and increases inductance, leading to an overall increase in Z0. Conversely, increasing the dielectric constant significantly increases capacitance, decreasing Z0 overall. This table summarizes the influence of key parameters on inductance, capacitance, and characteristic impedance. It serves as a quick reference for controlling your PCB trace impedance.